All right, looks like we're live. Hello everyone and welcome to another Azuzin session. How about that? Hello everyone, hello, Toby Prime, and Epic Pix, Akali, Mr. Botka, Ezin Grims, hello, welcome. So today we continue developing our programming language called Porth. That's right. That's what we'll continue doing. And so if you never heard about this programming language, I recommend you to check out its source code. You can find the source code here in the chat. And if you're watching live, you can find the source code in the description. So I maintain the file where I put things that I want to put in the description. So here is the source code. Okay. So it's a stack-oriented programming language. And for the past several streams, we were actively trying to implement features that will make the macros in this language obsolete, right? So let's take a look at the language itself. So we have a bunch of stuff in here, so maybe I want to actually clean everything up. I'm going to do git clean fdx. By the way, god damn it, I forgot to make a little bit of an announcement in our Discord server, right? Discord server, right? It's a Discord server. So let me quickly do that. So let's do the following thing. Red circle live on Twitch. And what we're doing today... Oh, we've got a sub. Thank you so much, whoever just subbed.
No,
Thank you, Ezin Grims, thank you so much for 5 months of tier 1 subscription. Thank you, and welcome to our Epic Porth Club. So we're live on Twitch, and right now we're coding some compiler. Right, so I'm gonna give the link to the Twitch channel, twitch.tv, and then I'm gonna ping everyone who's interested in being pinged. There we go. So we finally made a little bit of an announcement, hopefully. Hopefully we did it. All right, hello everyone, hello Archie, Levev7, Vekfi, Crazy Chicken, NP7S1, Yatka, 3 Lava, hello, welcome. So let me fetch the other stuff, and we're gonna take a look at some of this stuff in here. Nuffly, hello Nuffly, how are you doing? Let me merge everything. So here's origin master, original proc definition. Okay, so everything looks all right. So let's take a look at the language itself, right? So we're gonna include the standard library, right? So here's the standard library, and the hello world in this language will look like this. Hello world puts, right? And we're gonna just provide the new line, and then you can try to compile the entire thing, right? Let's go ahead and do that, and as you can see, it printed hello world. Right, it's a stack-based language, so first I push a string onto the stack, and then I use operation puts to actually print that string to the standard output. So this language has a feature called macros, so you can define a macro called hello, right, and just wrap this entire code into hello macro. Then if you call this macro like so, it will basically expand into sequence of these operations, right? It will not be a procedure, right? And hello is not going to be a function called to that procedure. No, it is going to be like an expansion into sequence of these tokens, right? So if I try to run it, as you can see, it says hello world, but I can actually run it several times, and it will print hello world several times. So for the longest time we used this feature, these macros, as sort of like a procedure substitution until we actually implemented proper procedures, right? And proper procedures are a little bit better because they don't bloat the code so much. Since macros, they literally copy-paste the body of the macro every time you call to it, and that was really bad for our compiler, right? Because we started to re-implement the compiler in itself, right? If you look into the source code, into the folder with the source code of Porth, we have porth.py, which is the original implementation of Porth, and we have porth.porth, which is re-implementation, like in progress, re-implementation of Porth in Porth. And because we had really big procedures, right, for instance, like main, so here is the main, Also, we have a parsing procedure, and in fact, we were using parsing procedure like in 3 places. In all of the 3 places, this huge thing was always copy-pasted, which created an enormous executable. So to combat that, we finally implemented procedures, right? So I usually tend to not implement features unless they're actually needed, right? So yeah, it would be maybe obvious for some people to implement procedures, but I just didn't want to do that unless it solves an actual problem, right? So I didn't have procedures until I encountered an actual problem, the size of the executable, and only then I implemented the solution in form of a procedures, right? So I don't try to predict what kind of features we may need. Like, I'm not trying to do that. I'm just trying to encounter a problem and then come up with a solution, right? So that way we don't have like features that we don't really need. So that's how I am designing this language. I don't know if it's a good idea or not, but I'm trying it out. I'm experimenting. This is an experimental language. Anyway, so we implemented procedures, right? And now macros are not really needed for procedures anymore, because if you need some sort of like body of code that you want to reuse, you can just use procedure. So Azura Akimori says, finally able to catch a live stream. Pog, thanks for all the awesome content at Sodding. Thank you so much, Azura Akimori, for 100 bits. I really appreciate that as well. Thank you, thank you, thank you. All right. So, and right, another thing we used macros for. We use them to sort of divide our static memory into specific chunks, right? So we have a pre-allocated, we had a pre-allocated buffer of memory, and through use of macros, we decided that first n bytes of that memory is going to be one thing, like structure, for instance, the file name, like another n bytes is going to be, I don't know, like array of operations and so on and so forth. So we had to sort of give certain sections of memory names and also offset them. So, and this is one of the things we used macros for until we introduced the named memory regions. So now you can define a memory, for instance, name, and you can say allocate like 32 bytes for the name. And there you go. So you have a chunk of memory of the size of 32 bytes, and you can refer to it just like you would refer to a memory. So we don't use macros for this feature anymore. Right, so we don't use macros for memory allocation, static memory allocation specifically. We don't use macros for procedures anymore, but there is one use case where we still use macros. And we use them for defining constants, right? So if you take a look at the standard library of Porth right now, we have shed ton of constants which represents Linux syscalls, right? So Linux syscalls have specific numbers, and it would be better for those numbers to have names, right? And that's what we use macros for. So, and at compile time, these names will be substituted with specific numbers and stuff like that. And in the Porth reimplementation of Porth, we have, you know, a lot of constants that represent different intrinsics and whatnot, and we also use macros for that. So, since we kind of eliminated all of the use cases for the macros, I think we might try to eliminate that use case as well and get rid of the macros completely. And I really want to get rid of the macros because they're kind of a pain in the ass to implement in such a dumb language as Porth. Right? So I want to have a set of simple features that are easy to implement in Porth. So, and because of that, I'm trying to get rid of the macros completely. Right, so what we can do here, we can introduce constants, right? Specifically, if you want to define a constant, like give a particular number a name, let's just have that feature, right? Let's have a feature that allows you to say, I don't know, something like const n 69. And there we go. Every time you use n, you actually push 69 onto the stack. But what's interesting is that some of the constants may depend on other constants, right? And some of them may be computed through arithmetic operations, right? So, for instance, maybe I want to have two constants, n and m, and another one, k, is going to be the sum of these two. Right, but I still want this thing to be a constant, right? But I don't want anything complicated. What's interesting is that we already kind of have this situation for the memory, right? So, and in the memory definition, we solved it the following way. If you want to define a particular region of memory, You can use actual Porth in here. You can do mathematical operations, and they're going to be computed at compile time, right? And here you can use a very small subset of Porth that is going to be executed at compile time and then used as the size of the memory. What if we do the same for the constants? So the constant definition is essentially going to be almost like memory region definition, except it doesn't allocate any memory, it just computes the value of the constant. You see what I'm talking about? So yeah, let's just literally reuse the same sort of compile time evaluation engine that we use for the memory, and let's reuse it for the constants, right? And yeah, that way we won't need macros anymore, right? So for all of the use cases we use the macros for, we're gonna have a specific feature that is easier to implement than the macro system. Yeah, so that's basically the idea for today's stream, right? So, and that's precisely what we're going to be doing today. We're going to be implementing constants that are like memory regions, but they don't allocate the memory, they just compute at compile time the value that you can use at compile time, right? And every time you use this thing, it basically just translates to push a number on the stack, and we won't even need to extend the intermediate representation. We can just reuse whatever operations we have in the intermediate representations. All right, so let's go ahead and do that. Sounds good? Sounds Gucci? Sounds Tamaguchi? Okay. So let me see. So maybe I want to actually remove everything from here. Git clean fdx. And let's create a separate branch called consts. There we go. So what I'm thinking is that maybe we want to have an example. So consts.porth, right? So here's a const.porth. And let's define const n. So first of all, we need to have some sort of a support for the editor, because right now our editor doesn't even highlight the const keyword, right? So let's go into the Porth mode, right, and find all of the keywords, and let's add the const keyword in here. So this is going to be the const, and this is for Emacs, and for the Vim, we're also going to have this thing somewhere here. So where is the list of the keywords? Here it is. So here is the const, and super quick, I'm going to go into my folder where I keep all of the extensions. Emacs.local, and in here I'm going to copy paste porth.mod. There we go. So if I restart my Emacs, and there we go. So so in Porth and consts.porth. There we go. So now we finally have a highlighting for the const keyword, right? So we can finally work with this stuff. So the first constant is going to be 69, right? So the second one is going to be 420, right? And it's not 420, it's something like this. And the third one is going to be basically the sum of these two, n, m plus. And the thing I want to do in here, I just want to print all of them, I suppose. Let's actually do n print, then m print, and then k print. There we go. Let's print all of them and see what is going on. Alright, so if I try to compile the example, so this is going to be const.porth, it is going to say that it doesn't know anything about word const, because it's not even a word, it's more of a like keyword, right? It's more of a like keyword. So what we need to do, we need to go to the compiler and add const to the list of keywords, right? So here we have procedure, memory, and so on and so forth. Let's introduce const. There we go. So by doing so, we actually will break the compiler. So the compiler will now ask us to add the const to this table. There we go. So now it has a name. And let's go to 10. This is going to be 11. There we go. So where is the other place where it breaks? Okay, so now we are inside of the parsing, right? So we go straight up into the parsing. And if we encounter a keyword, we have to do a special thing in here. So here are keyword while, do, include, memory, and so on and so forth. Nothing particular special. So maybe I'm gonna actually put the handling of const somewhere in here. So this is gonna be something like const. And here I might do something like assert false. Parsing of consts is not implemented yet. There we go. So I just want to see if it's going to tell me that you have to, like, if this assert is gonna fire. Okay, so it fired. So this is the next thing that we need to do. Okay. So first of all, we need to check if a name for the constant was even provided, right? So we're gonna do something like this. So if you have enough tokens, right, expected const name but found nothing. If you don't have enough tokens, it's supposed to actually tell you that. All right, so let's actually test that specific error. So the easiest way to test that is to just comment out everything except a single const keyword. And it will tell you expected const name but found nothing. Okay, there we go. So if you provide the name, right, it will advance the execution. Okay, cool. So the next thing we need to do, we need to try to get the name, right? So let's actually put this thing in here. Expected, not really memory name, but const name. Right, but found something else. So this kind of error will happen if you try to use, for instance, a number instead of a word, right? So, and it didn't even trigger anything, which is kind of sus, not gonna lie. So type is not equal. Excuse me, so what did it say? What the compiler said actually? Parsing of const is not implemented yet, so it was... so here is the const, here is the number, right? And in a const, we take the next thing, we check if it's not a word, and if it's not a word, we actually say, well, it's not a word. Maybe one of the things I want to do in here, I want to print the token and just like understand what the hell is going on in here. It is in fact word, and the word is equal. Oh shit! That is very interesting. We found a bug in the lexing. We actually found a bug in the lexing. Believe it or not, that is very freaking interesting. Oh shit! I have an actual idea. So we can try to do something like a bug, bug.porth, right? And if you have something like 69 print, this will not compile. Believe it or not, it will just not compile with the current compiler, right? Yeah, unknown word 69//. So to make it work, you have to add a space in here, and now you have just unhandled data in here. But we can actually do something like this, right? So let's actually run the entire stuff, right? So it says 69, but if you put something like this, it says unknown unknown word. You know what's interesting? I think there is no such bug in Porth, because in Porth I handle comments slightly differently. So let's actually compile Porth with itself, right? Let's compile Porth. There we go. So it takes some time, by the way. Python is a very fast language, so it takes some time to actually compile Porth with itself. Majority of the time is taken by the type checking, by the way. So I think if we simplify the type checking, we can actually speed up the compilation of Porth with itself. But anyway, we have a Porth that is written in itself. So you see, this is the Porth. And if we try to simulate the bug, right? If we try to simulate, it actually works. Look at that. It actually works. We can also try to compile this entire thing, right? So, and the compiled version also works, and the simulated version also works. So, if you try to now use the Python version of the compiler, it says unknown word. So we kind of like don't have that bug in a Porth specifically. We only have it in Python, right? So we only have it in Python. So should I report it? Should I care? Because I'm planning to completely get rid of the Python version So, and there is no such bug in Porth. So I'm just like, do I really care? It's a good question, actually. That's a good question. Maybe I don't care, but yeah, that's a very interesting one. Might as well to like just at least put it to do and see. Maybe I want to fix that at some point. But yeah, it's something that just to keep in mind. It is just something to keep in mind. Okay, let me see. So where should I put that? Where we handle the comments? So this is the place. Looks like this is the place where we handle the comments. So lex lines. Though the reason why we don't have that in Porth is because in Porth we don't support strings. Maybe after I add support for the strings, we're gonna have like a similar problem. I don't know. Okay, so let me put the to do in here. So this is gonna be to do. Okay. To something like 69 / is recognized as a single word, right? And not a number plus a comment, right? So we want to be able to somehow lex that slightly differently. All right, that's actually pretty cool. I think this is something important to keep in mind, and we discovered that bug on the stream, right? So, but for now, I'm gonna just like put it on the back burner. So Azura Akumore is gifting 1-tier sub to Toding community, and that sub goes to ComFix21. Thank you so much for gifting the sub, and ComFix, welcome to our Epic Porth Club. Alrighty, so let's remove all of that stuff. I'm gonna take a look at that a little bit later, and okay, let's continue. So in this case, it should fail, right? So now, well, I mean, I'm trying to simulate a wrong thing. So this is going to be const. It's a const s, right? Const s. Okay. Expected const name to be a word, but found an integer. Okay, makes sense. It does in fact make sense to me. So const. Let's remove this print. Let's remove this print, and that is already okay. Now, after that, so maybe we want to keep track of the const name, right? So we have a const name, which is the token value. We also want to have a const location, right? So we want to keep track of the const location where the constant was defined. And we also want to check for the redefinition of the constant. Okay, so now we want to add constants to here, right? So we have a special procedure called check word redefinition, and it basically checks if you don't redefine the words that exist. And we have words that define memories, macros, procedures, and now we need to have words that define constants, right? So this is going to be a dictionary that maps a string into the constant, right? And the constant is going to have a name. Well, I mean, name is already located in the dictionary, so it's going to have a name. Okay, it's going to have a value and the location. I guess that is basically it. So we'll probably have to do something like a data class, class const, and this is the value, and it's going to be just an integer, right? So this is going to be just an integer. This is going to be just an integer. Okay, so let me go and just do something like n, and let's see. All right. Const is not defined, so let's see where we have to define this entire stuff. So we have a bunch of dictionaries in here. Here are the macros, here are the memories, here's the procedures. Let's define const. So this is going to be dictionary that maps strings into the constants, right? There we go. If we try to recompile, parsing const is not implemented yet. Good. So here is an interesting thing. Now we need to start evaluating the compile time expression. So essentially we have to copy paste this chunk of code into the constant. I have nothing against copy paste, right? But I think this is too big. So what I'm thinking is that we need to extract the compile time evaluation to a separate function. So def, so we're gonna do def eval const value, right? So this is gonna be eval const value, and let's just grab this entire thing, right? So that must be a single number, and I think what I want to do in here is just go back. Eval, and I'm gonna just put this entire code in here, right? I don't care if it's gonna work or not. We're going to be using static typing to actually tell us what exactly needs to be changed in here, right? We're gonna use a little bit of a compiler assisted refactoring, so my favorite thing to do. So. 1, 2, 3, 4. There we go. All right. So memory, and now where is the memory definition? So the memory definition is so small that that I keep skipping past it. Okay, so this is where it was. So here is the memory name. Memory size stack. I don't think it's needed anymore. What we have to do now, we have to do eval const value, right? So cool. So we have a memory name, memory location. We check for the redefinition, right? We'll probably have to also use consts. And then we evaluate the memory size by evaluating this expression, and then we just define this entire thing. Okay, and a similar thing needs to be done for the constants, right? So we're gonna have const value, right? Here's const value, eval const value. There we go. Eval const value, and after that we just need to add that to the constant definitions. So this is gonna be consts, const name, const. So the value is probably gonna be the const value that we just computed, and location is gonna be the const location. And after that, I think the parsing of the constants is implemented pretty much. Right, so we just check if the name was provided, then we just evaluate the compile time expression, and that's it. We just add it to the definition. That should be enough, I think. So let's try to recompile the entire thing, and now it fails. It fails in here. Okay, so this is actually good because now I can try to use static typing for the compiler to tell me what I need to change. What I need to change, alrighty, so missing a positional arguments const to call check word redefinition. Okay, that makes sense, consts, and here is another one. Do we have to do anything else? What a nice compiler. Nice. Alright, so def, eval, so let me see. Oh, I know why, because I didn't provide any type annotation. So here's the thing about MyPy that I keep forgetting about, is that if you have a function without any type annotations, MyPy simply skips the type checking of that function. Diamond Drake 87, thank you so much for Twitch Prime. Thank you, and welcome to our epic Porth club. How about that? So essentially, since eval const value is supposed to return integer, let's actually say that it's supposed to return an integer. And I think after that, it will finally type check this entire thing. There we go. So it fails all over the place. So this is very interesting. I think it would be kind of cool if, I don't know, the MyPy would at least by default warn you that, okay, you have not annotated function, I'm skipping its like checking. It would be kind of cool. I'm pretty sure it has some sort of a flag. It's not what I'm talking about. It's just like I'm talking about, you know, good experience, good user experience by default. Right, by default, it's kind of meh. Anyway. Let me see. So what's talking about? It misses the return statement. Okay, so, and how we're gonna do the return statement? I'm going to just simply return mem size stack. So this was for memory size evaluation, but since it's not about memory size evaluation, we might as well actually rename mem size stack to just stack. So we're gonna do query replace mem size stack, and it's just gonna be stack. There we go. What is it talking about? So it's talking about our tokens. So we're gonna accept as a list, and it's gonna be list of tokens, right? So if I take a look at our tokens, let me see, where are they defined? Okay, so it's a list of tokens. Okay, that's fine. That is totally fine. So stack is not defined. Let's define the stack. So it's going to be like a list of integers, and this is going to be like this. There we go. Macros is not defined. Oh, okay. So that means we want to be able to expand macros within, like, while evaluating this entire stuff. Makes total sense. Furthermore, I would say that we want to be able to even expand other constants while evaluating this entire stuff. So I'm going to accept macros in here. So this is going to be a dictionary that maps a string into a macro. And also we're going to have consts as a dictionary that maps a name to a constant, right? So, and in here, I suppose I'm gonna add another condition, right? So it's gonna be elif token value in consts, right? And this is gonna be just assert false to do expanding other consts inside of consts. Definitions is not implemented yet. There we go. So this is what we're going to have in here. So it's quite important. Missing positional argument for the macros and consts. Okay, so we have to provide our tokens, macros and consts. There we go. So this is the last one. Our tokens, macros and consts. So I'm a little bit worried, right? So I expect our tokens to be sort of passed by a reference. And I'm not sure if doing something like plus equals actually modifies our tokens by the reference. Maybe it does, maybe it does not, but I'm not 100% sure. So this is something that I would like to check, in fact. Right, so imagine that I have a function that accepts access, and the only thing it does, it adds, 69 for 20 to access, right? So, and imagine that I have y's, and I have 1, 2, 3, 4 in here, which I want to print. Then I want to do something like this, and I want to print this entire thing yet again, right? So then if I do Python 3 foo pi, okay, so it actually modifies it by a reference. So I wasn't 100% sure because I'm not a Python developer, right? So I don't know the details of how this entire work, but this is the behavior that I need, right? So I suppose everything is fine in here. So is there anything sus left here? I didn't think so. Oh, it also talks about the memory definition. So I think I want to get rid of the mentioning of memory definition, so I might as well query replace in memory memory definition, right? So here's the memory definition. Let's just remove it. Maybe it's going to be like this: query replace and with additional space. Query replace with additional space. There we go. So, and let's see. So, let's do this thing one more time. Looks good. So let's do Porth.py, and let's compile constants. There we go. And they compiled. Oh, yeah, okay, that's cool. So we only compiled one constant. Can we try to print this constant? I think now this thing is not going to work, right? So if I try to do that, so it says unknown word n. Okay, so let's actually go ahead and let's take a look. Unknown word. So what we need to do in here, we need to do elif token value in consts, right? So we need to check if the word is in the table, and if it is, we're gonna add another operation in here. So, and the operation is gonna be just push integers. So we're gonna have integers for the constants for now. Op type push push integer. I think is just like push int. It's defined in this token, and the operand is going to be consts token value, and we're gonna just use this value, and we're gonna increment IP. I still need to get rid of the IP, so I'm gonna put a to-do in here. Consider getting rid of the IP variable in parse program from tokens. Like, it made sense at the beginning of the development, but now it kind of doesn't make any sense, because I think every time I need an IP, I can just use the size of the ops list. So I don't think this kind of variable is needed, because it's always equal to the size of the operations list. So it's kind of strange, right? If you know what I'm talking about. Okay, everything seems to be working. So now, if I try to run the program, it should say 69. Would you look at that? So we have constants. Well, to some extent. So you cannot use constants within the constants yet. So I think we need to fix that. So let's go ahead and actually test this entire stuff. So we're going to define the second constant in here. So here is the second constant. Might as well try to redefine the constant and see what's going to happen. And the constant was successfully redefined. The constant was successfully redefined, which is a bug, right? Which is a bug. So we need to actually fix that. Check word redefinition. Yeah, there we go. So that's kind of sus. If provided name is in constants, right? We have to say a compiler error with expansion stack saying redefinition of a constant s, right? So the constant s, and we're going to provide the name of the constant like so. And we also need to tell the user where is the original definition of this thing. So this is going to be const's name, location. The original definition is located here. There we go. And then we have to exit with non-zero exit code to indicate that there was an error. Okay, so here we go. We have a redefinition of constant n, and the original definition was here. There we go. Pretty straightforward. So, and if you define two separate constants, right? If we define two separate constants, it's totally fine. So, and now we can try to print both of them, 69 for 20. Cool. So the feature is coming together quite well, I shall say. It's actually a pretty easy feature. So we already have everything that is needed to implement that feature. So that's why it's so easy to implement. So is that name, comma, a Python thing, or just your future-proofing? Actually, both. Okay, so let's actually implement the feature that allows us to use other constants within the constant definition. So if I try to do something like this, it will tell me that, okay, so it straight up hit the to-do that I anticipated, right? Right, I anticipated that to-do. Expanding other constants inside of constant definition is not implemented yet. So, and that should be relatively straightforward, right? So if you encounter the constant, we take const token value and we get the value of that constant. And I think the only thing left in here is just push this thing onto the stack, and that should be it. Right, so we encounter the constant, we just take its value, we push it in the stack, and we evaluate it at compile time. Right, so that should be it. And so it's not a push, it's actually append. There we go. So this is the result of the sum of 69 and 420. 69 and 420. So, all right, so this example actually works. This example actually works, which is kind of cool. And what's interesting is that this is a purely parsing feature, right? So we do the entire constant computation and substitution entirely in a parsing phase, which means we never actually have to touch the code generation phase, right? So I never touched the actual code generation, the code that takes the sequence of operations and generates x86-64 assembly, and that just works. So that means this should work in simulation mode without any modifications as well. There we go, because it's purely parsing thing. Constants are purely parsing feature, so which is kind of cool, I guess. Okay. So let's actually go ahead and put the const.porth into the test cases, right? So we're going to put all of that into the test cases, and the next thing I'm going to do, I'm going to do test.py, and I'm going to update outputs for the test case consts, right? So const.porth. There we go. So it basically generated the expected output for this test case, and the expected output for this test case is these three numbers. Now we can try to go ahead and run this test, and it will run it for both compilation and simulation mode and confirm that that's exactly the expected output. Okay, so after that, I think it makes sense to actually run the full test suite and you know, commit and declare this feature done. So I'm going to use PyPy, and I'm just going to run the whole test suite. So it will type check both porth.py and test.py, run all of the unit tests, then run all of the examples, run the Euler tests, and then it will also try to compile the original compiler. I think the stuff that it does is actually listed in here. So you see, if you have a full test suite, so it just type checks, runs the tests for these three folders, and also tries to compile Porth with itself. Right, so this is like a full testing. So I do that full testing like every time after I implement the feature. So I just basically check if I didn't break anything. All right, so and we already broke something. Okay, not enough arguments for plus intrinsic in memory definition. Yeah, because I got rid of n memory definition, and this is part of the tests, right? This is part of the tests. So, and I'm not even sure. Okay, so let me actually quickly do the following thing. What if I update output for all of the tests, right? So for all of them. So how much difference are we going to have? How much difference are we going to have? Topic Prime asks, I suppose, about you know, recursive definition of the constant. So what's going to happen if you try to do something like this, right? So if we take a look at the code of porth.porth, right? If we take a look at the code of porth.porth, eval const value, maybe somewhere here. You see, we add the new constant definition after we evaluated the constant value, right? So before, like during evaluating the value, the constant itself does not exist there. So theoretically, such code that you actually mentioned in the chat should not compile. It should say that n is not defined, which is a good behavior, in my opinion, for the constants, right? I think it's a pretty good behavior for specifically for that. But let's confirm that, right? So, because all of that is theoretical, let's check that in practice. Let's check that in practice. So we've got a rate from Coder2K. Thank you so much for the rate. I really appreciate it. Hello, Ragers, by the way. How are you guys doing? So yeah, let's actually check if it's going to happen. So how we're going to do that? So I'm going to save recursive const, right? And this is going to be porth. There we go. So this is the recursive const, and let's see what is going to happen. So I'm going to do porth py compile run recursive const, and it says unsupported word n, right? So it just doesn't exist there. If you try to define n somewhere in here, right, so it will say that you're redefining n. So I think we kind of save in here. You see, so it's kind of like we don't really have a way to put malicious code in here that will go recursively or something like that. I think it's fine. Right. I think it's kind of fine. So, and to celebrate that, I'm going to add this piece of code into the test suite as well, right? So let's also update all the outputs one more time. One more time. Okay, so, and let's take a look. So unsupported word in memory, unsupported word. Okay, so I think that was a very dumb idea to just go ahead and remove mentioning of in-memory definition like from everywhere, because that generated pretty dumb error messages, right? So I think we'll have to go back and just come up with something more reasonable in terms of error messages. And something completely broken here, right? Exhaustive handling of keywords in parsing macro. Oh, this one is very interesting. So we caught like a bunch of interesting errors with this stuff. All right, I really like that. I really like that. So let's actually go in order with all this. Porth.py. So this is why we're writing tests, so we can actually, you know, catch all of this shit. So eval const value. Okay, unsupported keyword. In compile time evaluation, I suppose. In compile time evaluation, right? Not enough arguments for plus intrinsic. Okay, so that's fine. Not enough arguments for that intrinsic. Why does it plus for all of them? You know what, I think I should not use the direct name in here, because it's quite easy to, you know, make a copy-paste mistake. So I'm going to simply do token value instead, right? Because we know that value is equal to, well, we know that it's name and that that's an intrinsic name, so it means I can just do it like that. Okay, I think that's actually a better way of doing that. So it's going to be token value. There we go. So not enough arguments for this entire shit. The macro exceeds the expansion limit. It expanded this amount of time, which is fine. Unsupported word in like this in compile time evaluation. So we decided to call it compile time evaluation. In compile time evaluation, right? So, and then we also have this kind of... Oh, this is actually pretty cool. I think I didn't I mentioned that briefly on one of my streams, but then I expanded on that concept off screen, because I developed this thing off screen. So you see we have a function human that accepts a value and also a parameter called human number plural. Right, so it's actually a very interesting concept. I don't know why I came up with it, but here's the thing. So it's a function that returns human readable representation of an object that can be used in error messages. Right, so, and you provide a token type. And you can customize. Are you talking about a singular object or are you talking about plural object? In case of a singular object, if your object a word is going to be a word, integer, an integer, a string, a C-style string, a character, a keyword. If you want a plural, you're going to have words, integer, strings, C-style strings, characters, and keywords. So, and in the future, we're going to have like more different categories of nouns, I don't know, and stuff like that. So, and that way you can basically make, you know, better human readable, messages, right? So this is basically this function. And in the future, I actually want objects to be different kinds of objects. Maybe sometimes it's going to be like a union of something else, right? Something else. And it kind of creates a combinatorial explosion. And if the huge combinatorial explosion will happen, I will probably replace all of that with like tables and whatnot. But I think it's an interesting concept to have in your compiler, where you just have a table and you're trying to come up with the form of an object you're talking about that fits into your whole message, right? Does that make sense? I don't know, it's kind of interesting. Like, it's probably not necessary, but I kind of wanted to do that. So Ryan says, oh, Python have unions. Well, Python typing. So Python has optional typing, and within the optional typing system of Python, it does have unions, right? So they're kind of similar to, I guess, TypeScript unions or something like that. So we're using optional typing, and we're type checking with something called MyPy. which is external tool that understands the optional Python type annotations and can throw some, error messages, type checking error messages. So, and I'm gonna leave this thing in the description, of course, for anyone who's interested. So here is MapHigh, right? So, and I'm gonna put all of that in the description. So here's the source code and optional typing of Python 3. You can read more about this thing in here if you're interested, of course. And MapHigh type checker for Python, right? So you can find this thing in here. There we go. So why it doesn't have HTTPS? So it doesn't even support HTTPS. Don't use this tool. I'm joking. It doesn't matter. All right. So what else do we have? What I was talking about? I was talking about some other stuff. I need to go back. I was actually jumping a lot. I have too much crap in my return buffer. So compile time eval const value. Okay, so here's eval const value. So something, a token type in plural, are not supported in compile time evaluation. There we go. The result of the expression in compile time evaluation must be a single number, right? It must be a single number. Okay, cool. So and now I'm going to maybe re-evaluate everything. So let's actually update all of these things. And hopefully the error messages are going to be more reasonable now. Okay, so yeah, unsupported word in compile time evaluation. Yeah, unsupported word. Strings unsupported in compile time evaluations. Okay, the result of expression in compile time evaluation must be a single number. Memory definition, unsupported keyword if in compile time evaluation. Not enough arguments for intrinsic. So that's fine. Macros, and something is wrong with the macros. I'm not really sure what. All right, so one of the things we probably want to do, we want to try to execute this thing. So this is going to be porth.py compile and just to run and just see what's going to happen. So unknown. Oh, I'm an idiot. So it has to be porth. Yeah. Okay. So we have not exhaustive situation. Exhaustive handling. Okay, so this is a similar thing. So this one is going to be something like keyword consts, actually a single const. And there we go. So that was actually a relatively easy fix, I would say. Okay, so what do we have in here? And this is that, this is that, this is that. Stack under flow, here are all of the changes, here's that and that and that. So we also have a bunch of stuff that needs to be git ignored. I definitely want to git ignore this executable. I don't think it's needed. Git ignore consts, right, there we go. So let's do a full, test stuff. So this is going to be full. Does anyone have any questions while we're doing the full testing? Does anyone have any questions? Will Porth be able to interact with other C libraries? Yes, it will. But that's not priority right now. It will be able to support that in the future after we actually made it self-hosted. I love how the source is on GitLab. It's so easy to add an intrinsic in few minutes. I don't think it has anything to do with GitLab, to be fair. If the code is easy to modify, it rarely has anything to do with the platform that code is located at, usually. And I'm not even sure if that's the case right now. Is const proc on the agenda anytime soon? It is on the agenda, but only after self-hosting. How will you handle macros for storing loading? Storing loading is not really done via the macros. Storing and loading is done via the intrinsics. So I'm not sure what you're talking about. Oh, like, okay, so you're talking about the macros, like, you probably saw my code that has a lot of this kind of syntax. Okay, so for these kind of things, we're going to be using procedures for now, but in the future. Okay, I didn't want to spoil too much, but for this kind of like loading, storing things, I'm planning to have a built-in feature. Like straight up built-in feature. I'm going to explain you, because I think it's kind of interesting. So what you will be able to do, you will be able to define your structures, like actual structures. You will be able to define a struct, str, and then you'll be able to say, okay, so string consists of a count, which is an integer, and a data, which is the pointer to the sequence of the characters. And there you go, you defined a structure. You know how you can define a memory and just do something like this, right? And usually a size of is some sort of a constant, right? And it's going to be 60 or something. I'm planning to add a keyword var that will allow you to define regions of memory by providing the type that you just defined rather than the size. Right, so you define the structure, and then you define a variable name, and the type of that variable str, and it acts like memory region. It's just instead of providing the size, you are providing the type, right? So, and it's gonna act like pretty much like a memory region. By doing name, you're actually pushing the pointer to this entire thing. And on top of generating a structure, it will also automatically generate a bunch of names that allow you to access different fields of this thing. For instance, if you do something like str.count, it will take the pointer to the name and it will offset that pointer so it points at count. If you do std.data, it will offset that pointer to point at the data. Furthermore, if you want to read the actual value of the count, right, you'll be able to do something like this, right? So you push a pointer to the name, you offset that pointer to count, and then you read that value. Well, there will be an automatically generated shortcut for these two operations, right? You will be able to compress these two operations to just this, right? This will automatically expand to this. You will be able to still use both of the ways of accessing this thing. It's just like it's going to be syntax sugar that is automatically generated. Furthermore, something like this could also be sugared even further. If you just want to read the value of the count from the variable name, you would be able to do that like so. Right. That way you have a variable name and you take its field count and you automatically read it, and then you'll be able to print it. This is equivalent, this entire thing is equivalent to name str count, which in turn is equivalent to name str.count 64. And all of this like syntax sugars is going to be automatically generated for you. So it's not going to be like a macro or anything like that. It's going to be part of the language. So, yep. And the same thing for storing, right? So if you want to have a value, right? If you want to have a value, you want to store a value 69 into the count, you will be able to do something like this. You put 69 on the stack, you put a pointer to name on the stack, you offset that pointer to count, and then you save 69 by that pointer, right? So these two operations will have a shortcut like this. And saving something to the field of name is going to have a shortcut like this. So essentially, by doing that, you saving 69 into the field count. Right, an alternative writing for this thing is going to be name str, which will have an alternative writing of this. So you see, it's just like, it's going to be like the same thing. It's going to be the same thing. Yeah, and maybe we're going to expand the syntaxes at parsing time, right? So maybe the parser is going to actually expand this entire thing into like this sequence of instructions. So this is the plan I have for like loading storing macros that you actually mentioned. And furthermore, these structure definitions can be then embedded into the type system and type checked properly. Right, so we can then know if you're accessing the count, we know the type of the count, it's an integer. If you're accessing data, we know the type of data, it's a pointer, so then it can be hooked up into the type checker and just checked appropriately. So that's basically the grand scheme idea for structures and type system, but it's very, very far in the future. It's after we already made the compiler self-hosted. Right, and so this is basically how I envision that. Does it make any sense? Peter73RU asks, what is the usage for the language? This is a computer programming language. So this language is going to be used for writing computer programs. It's a computer programming language. So computer. Let's actually Google up what is a computer. The computer is a machine that can be programmed to carry out sequence of arithmetics or logical operations automatically. This is a computer. There are different kinds of computers, right? So, so here are examples of different kinds of computers. So this is a very old, big computer. And a modern computer actually looks like this. So you have like handheld devices. All of these things are fundamentally computers. And in computer science, such devices, such machines are usually programmed using computer programming languages. So Porth is a computer programming language. It's a language that is designed to program such devices. Does it make sense? Does it answer your question? Yeah, it's a computer programming language. It is designed to write programs for computers. What type of programs? The programs that are going to be executed on computers, on machines that can be programmed to carry out sequence of arithmetic or logical operations automatically. So, okay. All right, so I think it's enough questions for now. Let's take a look at our testing. Okay, so I don't see any problems with the current testing. So let's go ahead and actually do a committee. So the use case of this language is actually a very frequently asked question. So maybe I should actually put that into the README. I think I should put it into a README. Okay. So I'm gonna do a committee. Implement. Did I create this over much? Yes. Implement. Constants. There we go. And on top of that, let's actually update README. Okay, so it's like Porth. So Porth is a computer programming language. It's a computer. Okay, so maybe. Okay. The use case for the language. Porth is a computer programming language. it's designed to write programs for computers. Okay, it's a computer programming language. So let me see, I'm gonna give the link to the Wikipedia, because apparently a lot of people who ask this question don't really understand what is a computer. Right, I can see people in the chat saying, oh, it's like my mobile phone. Not everybody knows that your mobile phone is in fact a computer. It's in fact a machine that can perform a sequence of arithmetic and logical operations automatically. Right, and I think there was a Wikipedia article about computer programming languages. I think we should refer to this thing as well. Programming language. Okay, so is a formal language comprising a set of strings that produces blah blah blah. So that makes sense. Porth is a computer programming language. Alrighty. So oh goddamn Google. So let's remove this entire thing. Computer programming language. So maybe I'm gonna remove that, because people keep asking me about the use case of this thing, and I keep answering the same thing, so I think it needs to be put in the README. Document the use case for Porth, right? So now, from now on, it's gonna be in the README. Furthermore, let me actually quickly merge this entire thing. We need to create a command, right? We need to create a command for this entire stuff. So it's taking some time to actually push everything, so I'm already regretting to switch into GitLab. All right, cool. So let's go to the master. I think I can just do that, and I'm gonna try to merge the consts. There we go. I'm gonna push that right into the repo. Let's remove this entire stuff, and if we take a look, alright, so I'm gonna refresh this entire thing. So use case for the language, okay, that's cool. Do we have a link in here? So the Porth is a computer programming language, right? It's a computer programming language. It's designed to write programs for computers. Cool. So now, every time somebody asks in the chat or somewhere on the internet, what's the use case for this language? Redirect them to this section. Just like point them to this section. What is this language designed for? It's a computer programming language designed to write programs for computers. And I provided the link explaining what is a computer and what is a programming language. Right, because in 2021, computer science students don't understand what is a programming language and what is a computer. I think we need to fix that. We need to fix that. We need to finally educate people on what it is. Okay, so I'm also going to put that in the description. Right. The use case for Porth. Right, so this is going to be in the description. And let's also add the command. Right. Add cmd use case. This is going to be something like or one sender, and I think we're going to just like redirect. At cmd use case, and then at any point you can do something like use case. There we go. Here we go. Cool. So I think we're good. We're Gucci. We are Tamaguchi. That is very, very cool. All right, we have constants. How about that? How about that? Isn't that epic? I think it's pretty freaking epic. So maybe we're gonna make a small break, and after the break, we're gonna continue slapping some features on the language. How about that? So yeah, let's make a small break.